Welcome to lesson 7.6, finding equations for quadratic functions. So today we're going to be finding equations from graphical data, which basically means that we know some points on the graph and we're going to use them to find the formula. So if we're going to be doing this, let's start by writing the three forms that we use for quadratic functions. So the first one is ax squared plus bx plus c. The next one we've studied is that vertex form. And the third one is that factored form. So let's go through and say when we would use each of these forms. So this one is useful and we would want to use it if we know the vertex. This one is most useful if we know both x-intercepts and this one we're going to use as a last resort. It is much more challenging to find the answer using that form, but if you don't know the vertex or you don't know the x-intercepts, then we will need to use that final form. So let's go through and look at some actual graphs. So in number one, I'm going to look through and I'm going to start with the vertex right here. I'm going to say, do I really know the coordinates of that vertex? And it looks like I know its x value, but I can't tell exactly what that y value is. So I'm not going to use the vertex. But I do see that the x-intercepts look like they happen at nice coordinates. And the y-intercept also looks like it has a nice coordinate. So I'm going to use these 3 points. I need 3 because if I only use 2 points, then I would get a line, not a quadratic. There are lots of different quadratic functions that go through those 2 x-intercepts. So we're going to need 1/3 point to figure out exactly which one it is. So I have a point 2, 0, that's one of my x-intercepts, and a point -1, 0, that's my other x-intercept. And this is just any old other point, which happens to be the y-intercept, but it doesn't have to be the y-intercept for us to do this. So, since we're using x-intercepts, we're going to use this factored form for our formula. So let's see how that calculates out. I'm going to start with my general form. So in this case, I'll get x minus something else, and our 2 points are -1 and +2. So I'll get x plus 1 and x minus 2. But I'm not done because I have not found this a value yet. So I use my x-intercepts here, and what I'm going to use next is going to be that other 3rd point. which in this case had a y value of -6. And an x value of 0. So once I plug in that other point, I'll find that -6 is a times 1 times -2, so -2. If I divide by -2 on both sides, I will find that my a is 3. So my final answer in this problem, if I go back up here and fill in my a, y is 3 times x plus 1 times x minus 2. And I should leave my answer in the form that I used to find it. There is no reason to spend more time rearranging this formula. Let's try another one. So in number 2, if I look for the x-intercepts, it's not clear exactly what they are, but it does look like my vertex is at a nice crossing of coordinate points. So in this case, my vertex is going to be 4, 4. And just like before, there are lots of different parabolas that have that vertex. So I'm just going to need some other point somewhere to plug in. And it looks like I have that other point here at 1, 1. But I don't have to use that one. I could have instead used -2, -8, or 4, 1, or any of the other points on this parabola that are at nice intersections. And for number 2, because we knew the vertex, we are going to use this vertex form. Don't forget the square, or you're going to be writing the formula for a line instead of a parabola. So now I can take this vertex and plug it in. So that means my h is 4 and my k is 4. So I've gotten closer. I know that y is some number times x minus 4 squared plus 4, but I don't know what number that is. So here I plugged in the vertex, and here I'm going to plug in some other point. In this case, 1, 1. So 1 equals a times, well, 1 minus 4 is -3. Squared will be +9. I will subtract 4 from both sides. Divide by 9 on both sides. And I find that my a is -1/3. I should be pretty happy that my answer was negative because this one points down. So my final answer here is going to be y equals this a value, -1/3, and then the rest of it is as we found above. X minus 4 squared plus 4. So, to review for each example that we saw, for example 1, we saw that had the x-intercepts So we used factor form. In number 2, we saw that we had the vertex. So we used the vertex form. And it's as simple as that. So the next obvious question is, if you don't know the x-intercepts and you don't know the vertex, then how would you find the formula for a quadratic function? So let's try example 3. If I just know 3 random points with no other information about those points, how would I go about finding a formula? So, what am I going to use? For a formula where I don't have any specific information about the vertex or the x-intercepts, I'm going to my last resort, this ax squared plus bx plus c formula. So let's go and plug these in. So I'm going to start with my point 1, 4. So I have the y value 4 equals a times the x value squared plus b times the x value plus c. So this gives me the formula 4 equals a plus b plus c. If I look at the next point, 1, negative 2, negative 1, negative 2, then my y value, negative 2, equals a times negative 1 squared plus b times negative 1 plus c. So negative 2 is a minus b plus c. And then I'll do the same with the last point. My y value is 13, so 13 equals a times 2 squared plus b times 2 plus c. So 13 is 4a plus 2b plus c. So now I have a system of 3 equations with 3 unknowns, and if I solve this system, then I will find a, b, and c, and then I can plug them back into the formula to get a nice quadratic with x and y in it. So I'm going to start here with the first equation and solving for one variable so I can substitute into my other equations. So 4 minus a minus b will be equal to c. So I'm going to plug that in to each other equation. So here I have negative 2 equals a minus b plus this c value, 4 minus a minus b. So that will simplify if I subtract 4 from both sides, negative 6, and I'll get a minus a, which cancels, and negative b minus b, which will be minus 2b. Solving that, I find, by dividing by negative 2, that b is 3. Let's go back to this third one. 4a plus 2b plus I'm going to plug in my c, which is 4 minus a minus b. Subtract 4 from both sides and combine like terms. 4a minus a is 3a, 2b minus b is plus b. And now that I've plugged in what I got from my first equation, I'll now also plug in what I got from my second equation. Where I found that b was 3. Subtracting 3, dividing by 3, I find that a is 2. Now, if this had been some crazy formula with a's in it, I'd still be able to get a here. I'd plug that back in here to get b. Once I know a and b, I plug them both in to the first equation to find c. So 4 minus my a value minus my b value is my c. 4 minus 2 is 2, minus 3 is negative 1. And now I know a and b and c. So let's plug that back into this original formula to get my equation. So y equals a, negative 1, not negative 1, a is 2, x squared, plus b, just 3, x, plus c, which is minus 1, so that is how we find this equation. So you see that it is a whole lot more work than when we knew the vertex or knew the x-intercepts, which is why we only use this method as a last resort. So let's do problem 4. So we're going to use the function we just found in number 3 to predict the y value when x is 10. So once you have a formula, this is pretty easy. I want to know the y, and I know the x is 10. So I'm going to plug 10 into my formula. So I find that y is 200 plus 30 minus 1, which is 229. Let's try one last example. So this one, we're given a formula that we're going to have to use. So here, the situation is that a rocket is fired upwards, and at the end of when its fuel runs out, at the end of its burn, it has an upward velocity of 147 meters per second, which means that 147 is that initial velocity, the velocity at time 0, and it's 73.5 meters high, so that is that initial height. So before I even attempt to figure out how to answer any of these questions, I'm going to plug into my formula and turn all of these variables, these v0s and h0s, into numbers. So we have a formula for h, the height, negative 4.9 t squared plus V0, which is 147, T plus H0, which is 73.5. And my hope here, it's not going to always work out, but my hope here is that maybe 147 and 73.5 are divisible evenly by 4.9, because then my formula will be much simpler. So let's try it. 147 divided by 4.9. Yep, that comes out nice and evenly. And 73.5 divided by 4.9, that also comes out nicely. So I'm going to rewrite my formula by factoring out the negative 4.9 in the hopes that this makes later parts of the problem easier. So if I'm factoring out a negative, that will be minus, and again, minus. So now I have this much better looking formula. So now that I have a nice looking formula, I'm going to go and try and actually find the answers to parts A, B, and C. So the maximum height. Let's look at this formula. It starts with a negative for its A, which means that it's going to have this kind of shape. So the maximum height will happen at the vertex. So let's start by finding the x-coordinate of our vertex. Now I'm not going to write x equals because I actually don't have x's in my formula. I have t's. So I'm going to write t equals. And in this case, I want to find negative b over 2a. So I'm going to do these nice numbers, but you could do the ugly numbers and you'd get the same result. So I have negative of negative 30 over 2 times 1, which is going to give me 15. Now t is a time, and we're measuring time in seconds. Now let's find the y value of my vertex. And again, I don't have y, I really have h. And my h value is going to be whatever I get when I plug in 15. So I'll plug in 15 squared minus 30 times 15 minus 15. Calculator time. So 15 squared minus 30 times 15 minus 15 is negative 240. I take that answer and multiply by negative 4.9, and I find my answer 1,176. And I'm measuring heights in meters. So let's go back to the questions. A was, what is the maximum height? So the answer to A is 1,176 meters. Part B, when did the rocket achieve that maximum height? Well, we already calculated that. That was 15 seconds. Okay, C is about when it reaches the ground. So what does ground mean? Ground means that the height is 0. So let's go back to this formula that I had and figure out when the height is 0. So I'll replace h with 0 in my formula. And now that I have an equation here, right, here I had an h, so I didn't want to divide by negative 4.9 because that would be h over 4.9. It would get ugly. But here, now that I have 0, let's just divide by negative 4.9. So now I have a nice equation that I can solve with any one of my methods: factoring, completing the square, explicit roots, or quadratic formula. And because this one does not factor, I'm going to use one of my other methods. So today I'll use the quadratic formula. So I find that t is negative b, so positive 30, plus or minus the square root of negative 30 squared, which is 900, minus 4 times 1 times negative 15, so it'll be plus 60, all over 2 times 1, 2. So let's work that out. 960 is divisible by 16, is divisible by 64. So let's pull that out. 30 plus or minus 8 root 15 all over 2. I'll divide out the 2 so that I don't have a fraction anymore. So let's figure out more or less what these values are. So if I did 15 minus 4 root 15, I'd get a negative answer. And if I did 15 plus 4 root 15, I'd get about 30.49. So this negative answer does not make sense in this problem. So I only want the positive answer. This is a t value, so it'll be in seconds. So my answer to part C is that I will get 15 plus 4 root 15, which is about 30.49 seconds.